Alright, so I take it you were able to solve this problem okay. Finding your way to Hawaii, finding the distance and the direction, is almost exactly like solving this problem. There are a few differences, and these are differences that I wouldn't expect you to know, because in your regular geometry class you don't talk about these types of things. So I'm going to introduce some new concepts that I know that you haven't seen before. And what I'm going to tell you, I'm going to give you a lot of information all at one time, and I know full well that after you watch the video clip, you're going to be sitting there and you're going to say to yourself, I didn't understand everything that he just said. And that's okay. What I'm going to do is, after the video clip, I'm going to include a little write-up with some examples, and it'll be there on the website. So watch this video clip. Don't worry if you don't fully understand it. Work through the examples on the website, then come back and watch this video clip a second time. And then that second time it'll make a whole lot more sense. And if necessary, go back and redo the examples again, and then come back and watch it a third time. Okay, so now, first off, let's make sure that we understand what it was that I want you to do. Let's make sure we understand the problem. Okay, what I told you was our latitude and longitude and Hawaii's latitude and longitude. And I said, find the distance, find the direction. Okay, so let's use this orange to help understand the problem. Okay, this orange is the Earth. Here's the North Pole, here's the South Pole. Let me go ahead and draw an equator on here. Pretty poor looking equator. That's the equator. One other important thing that we need to have on here is we need to have the prime meridian. In other words, we need to know where Greenwich is. So let's say that dot right there, that's Greenwich, England. So the prime meridian then comes down like this. So this place right here, this is 0, 0. So when I told you that our boat's latitude was 29 degrees 48 minutes, tell you what, let's forget the minutes. Let's just work in degrees. Let's just round it off. So our boat's latitude is 38 degrees. What that means is, if you start at the equator and you come up to the North Pole, that would be 90 degrees. So halfway is 45. So 30 degrees is somewhere right about there. So we're 30 degrees above the equator. Now our longitude, we said, was 135 degrees. So I mean, start here at the prime meridian. So if we go around all the way, 180 would put us here. So 135 is going to be right about here. So there's 135 degrees longitude. Here's 30 degrees latitude. So right here, that's where our boat is. Now let's do the same thing with Hawaii. Hawaii was 21 degrees latitude. So that means we start here and come up about 21 degrees. So that's somewhere right there. Hawaii's longitude was 158 degrees. So again, okay, that's 0, 180, 158 is right about there. Okay, so there is Hawaii. So here's the boat, here's Hawaii. What I want you to do is I want you to find this distance right there. Does that make sense? Okay, now, let's look at this. This is not really a straight line, obviously, because the orange is a sphere. So if I want to know that distance, I've got to look at it a little bit differently. Let's take this knife. You probably thought it was just a coincidence that we happened to be in the galley when we were doing this. No, I planned this out. Let's take this knife. Come on in a little closer here. Okay, what I'm going to do is I'm going to cut exactly on that line, and I'm going to make the cut so it goes through the center of the Earth. So there we go. There's the center. I better not. I want to eat this thing afterwards. Okay, so here's the center of the Earth. Where we go? Okay, here's our boat. Here's Hawaii. So the angle from here to the center of the Earth to here, that angle is what we're going to do to measure the distance. If we can just figure out what that angle is, then we'll know what that arc length is, because that's why, remember from geometry, that's why arc length is measured. Arc length is the number of degrees It's equal to that central angle right there. So if we can just figure...
How strong is this gale force wind supposed to get?
Oh, hang on a sec. Okay, cut.